Okay, let's talk about the invisible engine that runs our world. Seriously, behind almost every smart system you use, from getting a package delivered to your door to navigating rush hour traffic, there's this hidden science making it all work. Today, we're going to pull back the curtain on that science, the science of making incredibly smart decisions. I mean, really think about it for a second. How does a package you ordered yesterday from a warehouse hundreds of miles away show up on your doorstep this morning? Or how does your mapping app instantly find the absolute fastest route across town, even avoiding an accident that just happened? Well, it's not magic, it's math. And it has a name: Operations Research. At its core, operations research, or OR for short, is all about using really advanced math to make better decisions. It's about looking at a ridiculously complex problem with a million different options and finding that one single best possible path forward. You could almost call it the science of choice itself. So to get a sense of where this whole field is headed, we did a little experiment. We took a snapshot, a core sample of the absolute cutting edge, by looking at every single new research paper published on the academic server arXiv in this field for just one day, September 30th, 2025. We found 102 papers, and in them, 3 huge trends just jumped right out. The first trend? Well, it wasn't subtle. It was a complete and total invasion. It seems the future of making the best possible decisions is absolutely tied to artificial intelligence. You know, reading through these papers was just wild. AI was reflected in every single direction. The biggest pattern, by far, is this fusion of old-school, powerful optimization math with modern machine learning. It's not just about solving a problem once anymore. It's about building systems that learn how to get better and better at solving it over time. And look, these aren't just buzzwords we're throwing around. These terms are pulled straight from the titles of dozens and dozens of those papers. Things like reinforcement learning, which is basically teaching a computer by trial and error, or federated learning, which lets AI train on data without violating your privacy. These are now central to the field. AI isn't just a tool for operations research. It's becoming the very language it speaks. And this right here shows you the difference perfectly. See, classic OR could create the most efficient schedule for a factory based on the data it has right now. But OR with machine learning can actually predict when a machine is about to break and reschedule everything on the fly. It's the difference between a static map and a live one that adapts to traffic as it happens. We're moving from fixed plans to truly intelligent, dynamic systems. So that brings us to the second trend. What do you do once you have all this new AI-powered decision-making ability? Well, you pointed at some of the biggest, toughest problems we've got. Yeah, this research isn't just happening in a vacuum. The second major theme we saw was a laser focus on using these techniques to solve real, tangible, incredibly important problems. This isn't just theory. It's about building a toolkit for a better future. For instance, check out paper number 10 from our list. The title sounds pretty technical, but what it's really about is figuring out the absolute most efficient way to design and run airplanes that use hydrogen fuel cells. We're talking about using this math to make air travel way, way cleaner. And hey, remember that package delivery we talked about? Well, paper 87 is all about sustainable last-mile delivery. It's not just about being fast anymore. It's about finding routes that save fuel and even take into account that some of us want greener delivery options. And the impact goes way beyond just logistics. Paper 32 is all about making legged robots safer. It's using optimization to help them see and avoid obstacles in real time, which is a huge step toward using robots for things like search and rescue, or even as helpers in our own homes. Now this one I found fascinating. Paper 31 is about managing rideshare drivers waiting at an airport. But instead of just optimizing for the fastest pickup time, it actually proposes a lottery system to make the queue fairer for the drivers. It just goes to show you this science can be used to optimize not just for efficiency, but for equity and fairness too. Okay, so we have AI making OR smarter, and we have these super smart tools being aimed at massive problems. But there's a third really fundamental trend going on under the hood: the constant, relentless work of making the mathematical tools themselves better. Because here's the thing. To solve all those amazing problems, to make planes greener or robots safer, you need unbelievably powerful mathematical engines. And a huge chunk of the research from that day was dedicated to just that, sharpening the core tools. So on a really simple level, you can think of how a lot of these algorithms work like trying to climb a mountain in a thick fog. You start somewhere, you check your altitude to see how high you are, you feel around for which direction goes up, and you take a step. Then you just do that again and again and again until there's nowhere left to go up. You've reached the peak, the best solution. Now, you see a paper title like this one, paper number 7. Yeah, your eyes might glaze over a little bit, I get it. But in our mountain climbing story, this research is basically about inventing a much better compass. It's about finding faster, smarter ways to figure out which direction is up and exactly how big of a step you should take. Every single paper like this one makes the tools sharper for everyone in the entire field. So, what happens when you put it all together? You've got the infusion of AI, this intense focus on real-world problems, and the constant improvement of the algorithms themselves. What does it all really mean for us? 102. 102 new ideas, new algorithms, new ways to solve some of the world's most complicated puzzles. That's 102 steps forward in the science of making better choices. And all of that happened in just one single day. The pace of change here isn't a slow walk. It is an absolute sprint. So here's the real takeaway from our one-day snapshot. This hidden science that routes your packages and guides your phone's GPS isn't so hidden anymore. It's evolving at a shocking speed, it's getting smarter by borrowing the brain of AI, and it's being aimed squarely at challenges that affect every single one of us. Which really leaves us with one final and pretty huge question. As our ability to find the best possible answer gets more and more powerful, the most important decision we have left to make is choosing the right questions to ask in the first place. With tools this good, what is the most important problem that we should choose to solve next?